Before we proceed, just wanted to let you know we have 4 speakers today with lots of information. We are recording so that we can use this in other communities as well to spread this information. We do have people here from all over Colorado, from Erie and Boulder and Longmont and Elbert counties amongst us who have been active on this issue in Aurora and Arapahoe, etc. Our first speaker is going to be Shane Davis, who's a research biologist, and he's going to show us a PowerPoint and guide us through it that gives a really strong visual understanding of what this process is all about, this fracking that's come to Colorado because of our Niobrara shale underneath our feet. And Shane, if you want to go ahead. Also, Shane is the leader of the Poudre Valley Sierra Club, and he's been very active in getting out information to lots of communities.
As Sonia said, I'm going to take you through a journey, a visual journey, with a small video and some of the research data, the statistics that I've compiled to demonstrate the impacts of fracking in Colorado. And I've got a remote, so let's see if this works. Okay, the question is, what is hydraulic fracturing or fracking? A lot of you already know hydraulic fracturing is it's sort of got this acronym, hydrofracking or fracking. It's the process of initiating and propagating a fracture in a rock layer by means of highly pressurized fluids and chemicals in order to release petroleum, natural gas, coal seam gas, oil, or other minerals. This is the map of Colorado. What you're seeing here in blue are the actual oil and gas basins. All of these are in blue. These are actual targets for the oil and gas industry. So it comprises about 30% or more of the entire state of Colorado. More like about 42%. These are statistics pulled by the COGCC's website as of October 7, 2011. This is the latest update they have on the active number of wells, oil and gas in Colorado. And as you can see on the left here, Weld County comprises the most with about 17,388 wells, followed by Garfield County, Yuma County, La Plata, Los Alamos, Rio Blanco, and then 36 other counties. So it looks like you've got about 42 counties in the entire state that are currently being fracked. This is a density weld map. This is mainly Weld County. Every single red dot can represent up to 52 active oil and gas wells. As I mentioned before, Weld County alone has nearly 18,000 active oil and gas wells. Just a single county. This is where I live. I live right in the middle of this red stuff. And just here on the left, you're looking at Larimer County, where Fort Collins is up north, and they're actually being encroached on as we speak. This is a section map illustrating every single red dot. Again, those are active oil and gas wells. This is taken from Weld County. And keep in mind, again, the red dot can represent up to 52 active oil and gas wells. So it's clearly a plague through a lot of counties, especially Weld County. This is also Weld County again, as you can see right here. You're looking at this area where it's all blue, and the yellow area is zoned for exploratory units for oil and gas. Now, to set the geography, this is Fort Collins in the red area, but the red is actually yellow, so it is included in the exploratory units. This is all Weld County here. You can see that the oil and gas industry is moving northwest in this area. The reason why I'm showing you this is because you can see the invasion that is targeting Larimer County next. This could happen to any county. But this is a really good example to show the impact. This is a predictive modeling map of the state of Colorado with all the actual oil and gas basins targeted for 100,000 oil and gas wells. As we understand it, the industry is set to drill over 100,000 wells in the next 1, 2, 3 decades. And basically, this is what a hypothetical modeling map would illustrate that would look like. This is Weld County. It gives you kind of a illustrated point of view of what a sort of a medium-sized pad looks like. These black stacks here, those are called VOC stacks. That's where the volatile organic compounds are actually burned out from the system. The system has sort of a hiccup. There's excess methane and other vapors that get burned off as a volatile organic combustion. So this might be indicative. Every single one of these VOC stacks would indicate one separate well. So this well pad could have 6, 7, 8, 9 different wells on the actual location. It's just kind of a schematic of what you're going to see when you go through an area that's currently being fracked. You can see the derrick, which is right here on the left. That's the tall formation that allows the pipe to be drilled down in there. On the right-hand side, you can see these cylindrical tanks. Those are generally for chemicals. These right here are water storage tanks. They deliver these to the site empty. They hold roughly 20,000 gallons each. And then it takes several hundred, 400 to 600 actual tanker trucks to fill up water from your municipal fire hydrant or a river or wherever they're getting their water to bring it back to these tanks to fill them up. This is a recently fracked pad right next to a middle school in Firestone. The middle school is on the right here. Behind these concrete barriers, until they can get a fence set up, there are 3 wellheads that they just recently drilled and fracked. This is sort of the complex nature of what it actually looks like with these giant chemical tanker trucks. This is how they actually force the chemicals down into the wellbore itself. These are Halliburton tanker trucks forcing water, chemicals, and proppants at extremely high pressures down the wellbores to frack or fracture the shale formation to release the natural gas or oil. This is a sort of an illustrative diagram I put together to make it easy for you to understand all the parts and pieces, the general parts and pieces of a well site. You're going to see this tall stack right here. There are actually 3. You can see 1 here, 2 here, 3. These are volatile organic combustion flare stacks. The flame sits inside like a pilot light, like on your water heater at home. But whenever there's a hiccup in the system, in this separator, it releases methane and other vapors through an actuator valve, and those chemicals get burned off. So chances are you're probably not going to see it unless it starts initially, then it's black until it can reach full combustion heat, and then it's invisible. You'll probably just see a heat signature, that's about it. Down here you can see a berm. This berm is just piled up soils, rocks, to prevent any spill from actually migrating past the site. The berm is to protect the outside area surface if there was in fact an internal spill, so it would harbor any spill of liquids. Over here you can see these very common. These are called tank batteries. Basically it's a storage tank for the product or condensate. And then I'll get into the parts and pieces a little bit more as we move on. This is where I live. This actual tank battery is 118 feet from the nearest home, right across from it. 118 feet. This is in Firestone. Firestone historically had the area zoned industrial, and then they commingled high-density residential dwellings within and around industrial zoning, as you can clearly see here. This well site was there before the homes were built. But the setback on it's only 118 feet. I'm not sure if they're in compliance. It appears that they're not. Produced water. Everybody wants to know what produced water is. Basically, it's an industrial waste. Produced water is the water that is produced during the fracking operations. It's classified as an industrial waste and may contain highly toxic and carcinogenic chemicals such as benzene, xylene, toluene, ethylbenzene, naturally occurring radioactive materials, and many other potentially dangerous or lethal chemicals. This is stored underground, as you can see in this small tank here. The tanks usually hold a little more than 3,000 gallons. And then a truck usually will come through, suck it out, and take it off to a Class 2 injection well, where they'll dispose of it forever. So I just described what produced water is. It's a term that the oil and gas industry uses to describe the liquid that is produced along with their fracking operations. There are roughly 750 chemicals that can make up frac fluids. Generally, they use maybe a dozen to 2 or 3 dozen different chemicals for a frac job. Depends on the operator and what their recipe is. Hydraulic fracturing was exempted from the Safe Drinking Water Act and the Clean Water Act and the Energy Policy Act of 2005. So So this is what we're facing right now. Frac fluid is considered proprietary and is not regulated under the Safe Drinking Water Act. See right here? And it is, again, considered an industrial waste. This is an example of produced water, an industrial waste spill that happened in 2005 in Arapahoe County. It was a company called Renegade Oil and Gas. And what you're looking at here is their operation is right here. This is where their wellheads are. And they essentially have an open pit where they put in all their produced water. The berm on the pit, which holds the water in, breached. 210,000 gallons of produced water spilled out and went down into Cottonwood Creek down here. Did anybody ever hear about it? It was never published. So when you're looking at these, this is just one example of thousands that are out there. This is a big one. When you look at Suncor, just a couple months ago when they spilled 20 to 40 gallons of an oily substance in Sand Creek, the whole world was there. All the news media picked it up, and EPA and everybody was really concerned about the acceptable levels of benzene and other carcinogenic chemicals in the water. Well, we have no clue what 210,000 gallons does, especially that it drained into Cottonwood Creek, and none of it was recovered. It's still there today. This is Weld County. This is an actual oil spill. It happened, I'm not sure of the date, I can't remember the date. I believe it was just within a year and a half. But as you know, this is oil, so it is benzene that has been spilled out into this field. You can see quite clearly, it's quite deep. 2,100 gallons of this oil was spilled. 420 gallons were never recovered, so they still exist. They can't recover them. They don't know how. The groundwater depth in this area is 3 to 4 feet, as reported by the COGCC. Keep in mind, these are reports that the industry has to report to the state. So this is the state's information. Here's the same site. You can kind of get the sort of the size of it. There are a few gentlemen standing out in the field wondering, what to do. Looks like they've created a mock berm around the site spill area, and they're awaiting probably some other people to tell them what to do. A couple of things that I've been researching lately are actual spills, but the industry does not report any spills to the state. Now, an operator is mandated to report any spill over 5 barrels, which is 210 gallons. So they're mandated to report that spill to the state if it exceeds 210 gallons. Satellite images show these look like spills to me. I mean, the land becomes very sterile. You can sort of see the leaching down on the sides. Noble Energy actually owns all of these sites right here. And I researched it, and there are no spill incident reports for any of these 3 sites. And these are dated, I believe, well, this is taken in 2006, this satellite image. And there are no spill incident reports that I've found at all in regards to these specific well API numbers. This is very unique. This is in Erie. This is in Canna Oil, and you can see the residence right here. It's very close. It's within 300 feet. I want you to really pay attention to these little rectangular pits. These are produced water pits. And Canna actually employed produced water pits on site. It was legal. It still is legal now. But they changed their ways. And now they don't actually employ open evaporation pits, so where they can dump in hundreds of thousands of gallons of produced water. And here's the unique part. Keep in mind, this is 2007. This is 2010. They're filled in. Okay? We don't know if there's any type of remediation plan. I couldn't find any documentation on it at all in the state's website or from the state's databases. But nonetheless, this still exists. We don't know what the toxicity of the land could be. However, it's still by residential homes. People might walk their dogs. The children go out there and play. We don't know. They shouldn't, because this is an oil and gas well site. But it's unique, what satellites can show you. This is a new case, January 13th of 2011. COGCC requests emergency funding for explosive levels of methane seeping into occupied residential homes from plugged and abandoned oil and gas wells. It's very difficult to see on the COGCC's map, but there are over a dozen, maybe 2 dozen dots all over where these historic wells are. And they were drilled in 1909. But you can see here's the site where methane is seeping, but it's seeping into residential homes in their basements. Liquid methane at explosive levels. This was never reported in the news either. The COGCC has a gold mine of data that we need to get publicized because this is a huge, huge risk to human health.
Where is that?
This is in Florence, south of here, Florence, Colorado. My question again, are historic cement well bores really safe? This is a case that I researched last year. It's called the case of Mr. Anderson and his water well in the Laramie Fox Hills Aquifer. This is in Weld County, August 1st, 2009. Mr. Anderson filed a complaint with the state alleging an impact to his personal water well. And it was contaminated. He claims it was contaminated from mining operations that use hydraulic fracturing. The state tested Mr. Anderson's water well and found it had been impacted from fracking operations, thermogenic methane, and toluene, carcinogenic again. The state issued a notice of alleged violation to the oil and gas operator. It was determined that the well bore had 2 holes, not 1, but 2 holes in the production casing. The state determined that the oil and gas operator caused contamination, not only of Mr. Anderson's water well, but to the Laramie Fox Hills Aquifer. Now the key here is that this well was drilled in 1984, this cement well bore. The new operator came in 2009. They're using a historic well bore, which is naturally compromised over time. They're using high pressure technologies that they're using today. We don't know if that's a causal link that popped 2 holes in the well bore, contaminated the Laramie Fox Hills Aquifer and Mr. Anderson's water well. The state issued fines of $66,000, later reduced to $46,200 because the operator had a good history with the COGCC. And that's their own words. The well was then immediately plugged and abandoned by the oil and gas operator. Here's Mr. Anderson's residence, right here. And roughly 990 feet away is the actual well bore site. So you can see the migration is close to 1,000 feet. And it happened just almost instantaneously after they started fracking. Again, this is in Weld County, just north of Firestone, about 7 miles northeast. I recently ran statistics on 1,000 spill incident reports in Weld County. And what I found, 42.7% of all spills in Weld County appear to result in groundwater contamination. That's nearly half of all spills cause groundwater contamination. 3.1% of those 1,000 spill incident reports that I studied appear to result in surface water contamination. And 57% of all of those spills have a berm failure. So again, that berm is there to protect any migration of spilled liquids. So nearly half of all of the 1,000 spill incident reports I studied result in groundwater contamination. And this is data from the state's database. This is their own information. Question, where does all the potentially toxic produced water go? Class 2 injection wells. These are large open formations underground that the oil and gas industry pumps produced water, industrial fracking waste water down into where it remains forever. Basically, they deep six it to never return to the surface. A waste injection site has been found to hold up to 1.26 trillion gallons of industrial fracking wastewater. They're very, very large, some of them. The way they also potentially get rid of the water is pumping into streams, rivers, lakes, and open bodies of water. These are kind of rumors that we've heard in the past. Generally, from coal bed methane, they will do that because the lack of toxic fracking fluids would be sort of the indicator. Agricultural crops, livestock, they can use produced water. And then one that I've recently researched is spraying on dirt roads or out into the field next to the actual well pad site. And I'd spoken to some oil and gas employees of 20 years or more. And they confirmed to me that the industry does, or had in the past, actually dump their produced water on site. They'll take these giant trucks filled with the produced water out in the fields and just drive off. This is what I'm trying to show you here. Right here, you're going to see a well pad. And it's clear that this would indicate that whatever is being dropped on here is toxic enough to sterilize the land. So it looks like they probably just took their water truck, the produced water truck, and just drove off into the field and dumped it as they went. This is not one, this is a couple I want to show you. There are more oil and gas well pads here. You have more tracks out here where you have sterile areas near and around oil pads. Here's another one. So it looks like you've got about 6 well bores here. I researched this one, and you're going to see sterilization again. It's pretty spotty. If you can get a really good close-up, if you can see it close where Sonia's at, you might be able to see where the water actually just comes out. Again, this is what it appears to be. Here's another one. These are extremely toxic. I mean, to sterilize it in such a fashion that the surface actually becomes white, it's pretty noticeable. You can't run from satellite. And here's one where if you look really closely, you can just see, hundreds of them all over the place. This is in Weld County. This is north of Keensburg, about 5 miles north of Keensburg in Weld County, Colorado. So, what I did is I researched all of these well sites to find the owners, to find out if they had any spill release reports, to see all the information I could about them. Noble Energy owns all of these. So I sort of went in a circle to say, who's doing all of this? Look at all these spots. It's very curious to me. Evaporation pits is another way to get rid of produced waste. Basically, it evaporates into these giant pools that are 10 times the size of an Olympic swimming pool. Evaporates the chemicals into the air. These can hold millions of gallons of produced water. I don't have much time left, so I will speed through this. Phil's going to talk about this greatly. Do we have enough water in northern Colorado to support the oil and gas industry? Where is the oil and gas industry getting their water? And a statement from Dr. Robert Howarth of Cornell University. He states the average amount of fresh water needed for a single frac job is approximately 5 million gallons. A single well can be fracked up to 32 times in its lifetimes. Now, this is variable. Some people say 18, some people say 32. Dr. Walkner from Clean Water Action actually ran a study in Weld County and called all the cities to find out where they're getting their water from. And so far, 5 of them admitted they're selling their municipal water to the oil and gas industry. But I would imagine there's plenty more. Fugitive emissions risks. This is another impact that, as I showed you with the volatile organic combustion flare stacks, they include hydrocarbon gases released as VOCs. VOCs such as benzene, ethylbenzene, cyclopentane, and dozens of other chemicals pose a long-term health risk to workers and local communities. If methane emissions are contained in a building, there is a risk of explosion. As I mentioned, the case in Florence, Colorado, that's currently happening. Here's a close-up of the VOC stack combustor. It's about 25 feet tall. Generally, when you see these large ones, it's indicative that there are a number of well bores on site. It means they have a number of holes in the ground that they're pulling product. So they need a larger volatile organic combustion flare stack to burn off the excess, because their systems can't handle it. Again, it's like a hiccup in the system. And this is a short video. Let me just run through this real quick. This is a video taken from a helicopter. It's showing fugitive emissions through an infrared camera. And there's text on there, so please watch. Looks like it's running pretty slow. Looks like their system's running slow. Just bear with it a little bit. I won't go through the whole thing. Basically, what you're going to see with an infrared camera is you're going to see the signature, generally a heat signature from the invisible black smoke that they're talking about. Those are fugitive emissions. So essentially what this video is going to show you is what it looks like without the infrared camera and what it looks like with the infrared camera. This is the standard without, obviously, and then it'll switch to the infrared. So when you're driving past these, always try to think what actually exists. They're invisible. You can't really see them. But when you're standing right next to them, you can see the heat signature, and it's hot. It's really hot, but you can also smell chemicals as well. On a hot or a cold day in the winter, drive through Weld County. They look like chimneys everywhere. Little fires going. To save time, I won't go through the whole thing here, but you can sort of get the gist of this. This is in Firestone, Colorado. This is a children's playground right here. You're going to see volatile organic combustor stack right here. There's also one right behind it. I was there on this day, and I found this by accident, actually, a little over a year and a half ago, and realized something was happening. So I started digging in and realized that there's really no concern, I think, for special concern for children's and their susceptibility to any type of volatile organic emissions or anything like that. So I found it very troubling. This is a satellite image of the same location. You're going to see right here is the playground. These are actual well sites right next to the playground. This is the elementary school, and there is another well here. These are all active. So they encroach basically around schools. This is what a well pad looks like. General well pad, you're going to see 165 blue and red storage tankers. Again, these hold water, so this would be, this actual frac site would hold roughly or use 3.3 million gallons of municipal or fresh water to extinction. The water is never good again. The other impact is the lack of revegetation and reclamation on these sites. Satellite image in Weld County again. You're going to see these areas where there's lack of vegetation. And if it's hard to see, I've created the next slide to show you kind of a few of those. It's very dense. I've asked Dave Neslin and Margaret Ash, the environmental specialist for the COGCC. They want these images so that they can better understand why these are not being reclaimed by the industry. But I think more importantly, why isn't the state following up? It's their job. These are some other ones. Again, this is Noble Energy. You can see these spills, what look like to be spills, all along these areas. These are some more, and this will kind of give you a dimension. This is about the size of a football field, width and length, each one of these. So they're quite large. Here's another satellite image. The green ones are active wells, the red are non-active, but the lack of remediation, again, still exists. Looks like the moon, doesn't it? This is happening. These are wildlife trails going to and from sources of water. You can see thousands of wildlife trails. They all navigate because naturally that's how they do things. So I have concerns. These are all active oil and gas wells around here. And I'm unclear what this area here is. But nonetheless, it's a concern for wildlife as well. These are a few more. You can see some actual spills right here. These are clearly spills. They're wet. So what are some of the impacts? Vegetation loss, wildlife and habitat loss, endangered species concerns, air quality degradation, agricultural loss, real estate values decrease, soil contamination, as I pointed out, nearly 50%. Also groundwater and surface water contamination, road impacts, noise, water use to extinction. The water that they use never returns to the hydrological cycle ever again. So it's being removed from you in your future. Health concerns to include, endocrine disruption, death, asthma, all different kinds. Contaminated drinking water like Mr. Anderson's aquifer and his water well. Just real quick, I'm almost done here. Abandoned oil and gas wells, and how many are there, and are they a risk? I really think that abandoned wells are a huge risk because the industry is going in and they're re-entering old historic wells. They're refitting them and re-drilling deeper. The wells already exist. Why would they want to spend the resources to drill a new hole? Well, they don't have to. Colorado currently has 129,073 oil and gas wells of all statuses. 47,000, roughly, are active oil and gas wells in the state of Colorado. That leaves roughly 90,000 abandoned historic wells, many of them, or most of them, awaiting re-entry. The COGCC has 17 inspectors. Just last year they only had 15, now they have 17, so they're a step in the back of the world. Again, they have 129,000 wells. There are 47,000 active oil and gas wells and 90,000 inactive. So each inspector would have to inspect 2,764 inspections per year, per inspector. Now include the 90,000 wells, and those are mandated to be inspected at least once per year. That would equal 5,000, or actually 8,058 inspections per inspector per year, right here. So could one person inspect over 8,000 wells in a single year? My question is it a failure? The real question is, who's protecting our rights? What can you do? And we'll talk about that at the end of the Q&As. There is a rule called Rule 529 under the COGCC. It's a procedure for rule-making proceedings which allows civilians to make amendments to the way operators do business. It's tough, but we can do it. I'll let you read this one. I'm simply amazed that we are using the most precious natural resource, water, to mine for something far less valuable. There you go. Area. The reason why I'm showing you this is because you can see the invasion that is targeting Larimer County next. This could happen to any county, but this is a really good example to show the impact. This is a predictive modeling map of the state of Colorado with all the actual oil and gas basins targeted for 100,000 oil and gas wells. As we understand it, the industry is set to drill over 100,000 wells in the next 1, 2, 3 decades. And basically this is what a hypothetical modeling map would illustrate that would look like. This is Weld County. It gives you kind of a illustrated point of view of what a sort of a medium-sized pad looks like. These black stacks here, those are called VOC stacks. That's where the volatile organic compounds are actually burned out from the system. The system has sort of a hiccup. There's
in getting out information to lots of communities.
As Sonia said, I'm going to take you through a journey, a visual journey, with a small video and some of the research data, the statistics that I've compiled to demonstrate the impacts of fracking in Colorado. And I've got a remote, so let's see if this works. Okay, the question is what is hydraulic fracturing or fracking? A lot of you already know hydraulic fracturing is it's sort of got this acronym, hydrofracking or fracking. It's the process of initiating and propagating a fracture in a rock layer by means of highly pressurized fluids and chemicals in order to release petroleum, natural gas, coal seam gas, oil, or other minerals. This is the map of Colorado. What you're seeing here in blue are the actual oil and gas basins. All of these are in blue. These are actual targets for the oil and gas industry. So it comprises about 30% or more of the entire state of Colorado, where I live. I live right in the middle of this red stuff. And just here on the left, you're looking at Larimer County, where Fort Collins is up north, and they're actually being encroached on as we speak. This is a section map illustrating every single red dot. Again, those are active oil and gas wells. This is taken from Weld County. And keep in mind, again, the red dot can represent up to 52 active oil and gas wells. So it's clearly a plague through a lot of counties, especially Weld County. This is also Weld County again, as you can see right here. You're looking at this area where it's all blue, and the yellow area is zoned for exploratory units for oil and gas. Now to set the geography, this is Fort Collins in the red area, but the red is actually yellow, so it is included in the exploratory units. This is all Weld County here, and you can see that the oil and gas industry is moving northwest in this area, more like about 40–42%. These are statistics pulled by the COGCC's website as of October 7, 2011. This is the latest update they have on the active number of wells, oil and gas in Colorado. And as you can see on the left here, Weld County comprises the most with about 17,388 wells, followed by Garfield County, Yuma County, La Plata, Los Alamos, Rio Blanco, and then 36 other counties. So it looks like you've got about 42 counties in the entire state that are currently being fracked. This is a density well map. This is mainly Weld County. Every single red dot can represent up to 52 active oil and gas wells. As I mentioned before, Weld County alone has nearly 18,000 active oil and gas wells. Just a single county. This is.
Before we proceed, just wanted to let you know we have 4 speakers today with lots of information. We are recording so that we can use this in other communities as well to spread this information. We do have people here from all over Colorado, from Erie and Boulder and Longmont and Elbert counties amongst us who have been active on this issue in Aurora and Arapahoe, etc. Our first speaker is going to be Shane Davis, who's a research biologist, and he's going to show us a PowerPoint and guide us through it that gives a really strong visual understanding of what this process is all about, this fracking that's come to Colorado because of our Niobrara shale underneath our feet. And Shane, if you want to go ahead. Also, Shane is the leader of the Poudre Valley Sierra Club, and he's been very active.